All right, good afternoon, everybody. Welcome to our private well class webinar. Is my water safe to drink? Common questions about private wells. I'm Steve Wilson at the University of Illinois at the State Water Survey. And this program, our private well class program, is sponsored, funded, and supported through the Rural Community Assistance Partnership, which is a nonprofit I'll explain in a few minutes. And it's funded through US EPA. I want to mention that I woke up with a head cold. So please bear with. I'm going to pause to take a drink every so often and some of those things because my throat's pretty scratchy today. But I felt like we could still get this done. So anyway, let's get started. Yeah, again, this webinar is part of a national program, our private well class program. I mentioned RCAP and US EPA. So this started as a 10-lesson class for well owners in 2013. And though our webinar is going to follow some of that material, it's not the class. And if you haven't taken the class, whether you're a well owner or an EHP or someone else who works with well owners, I certainly recommend you sign up and take the class. It has a lot more detail. There's 10 lessons. It walks through, it's kind of a well owner 101 and walks you through understanding where your water comes from, well types, all those things, including treatment and things you need to be concerned about for testing, and in a lot more detail than we can cover in our 2 hours today. We do record all of these, and as it says here, if you go to the Private Well Class YouTube channel, you can see every webinar we've ever done, which is probably in the 140s or 150s now on a number of different topics. We'll talk about some of those today, but you know, when you signed up today, you all asked questions and we're able to put that in the registration. We'll answer some of those today, and so obviously not all. There's a lot more questions that we could answer, but every webinar we do answer, between, let's say, 6 and 15 questions. And so from that, if you go to those webinars that are recorded on YouTube, you can, like this webinar has been done since day one. A similar, this is a longer version today. It's got more detail and it's updated, but people ask us questions throughout. You can go and see questions, probably 150 questions just for this particular webinar that people have asked over the years that might be useful to you as a well owner. And I tell people they should just consider going and pulling up the video and skipping to the question part at the end, which we'll do today as well. And you'll learn more about topics related to having a private well. As we go through today, the other thing is, if something I say or you see on the screen you have questions about, put it in the chat or the question box that's in your window, and I think it's a chat window. Katie Buckley, who's here with us today, is monitoring that, and at the end we will pull up a sheet with all of the questions you've asked today, and we'll answer them as best we can. If I can't, well, I'll ask you to email us, and then we'll find an answer. We work with folks all over the country so that we're able to do that, and yeah, we should be able to help. All right. If you're on here today and you're a professional who's getting CE credit, we're a provider for continuing education credit through NEHA and through Illinois Licensed Environmental Health Program. So for NEHA, which offers credit in many states for their environmental health professionals, you have a 2-year credentialing cycle. So the example I threw up here is, if your credentialing cycle started at the beginning of this year and you take the class today, you can't take it again and get credit for it, the one that's titled with this particular webinar, until after 1/1/28 when you start the new credentialing cycle. And to follow up on that, if you were on this webinar in February, then you can't get credit today, or you shouldn't. So we provide lists here. You can email us at info@privatewellclass.org. And actually, this has changed because now we ask at registration if you're going to want a certificate. And so that should happen automatically. You shouldn't have to do anything. But if you need anything else, like a copy of the slide deck, I know we have some other folks on here, like a few well drillers who may be able to get credit in their state. If you need any of those other things, let us know. But and again, we do record these, but and it says right at the beginning of the recording, once we put it on our YouTube channel, that you can't get credit for watching the recording. Just to make that clear, you really need to attend live, and we need to see that you were here the whole time. And yeah, we have a number of criteria we use to decide, and we don't get partial credit. So yeah, anyway, that's what we've decided to do. The idea here is to learn, and so hopefully everybody gets something out of today. So again, I'm Steve Wilson. I'm a groundwater hydrologist, and all three of us are at the State Water Survey. Katie Buckley's on. She is fielding the questions. She does all the CEU work. Many of you probably know her from that are involved in those things. And then Sally Dolan, also, who manages our help center, helped with some of the slides today. So I mentioned RCAP earlier, the Rural Community Assistance Partnership. So they're a nonprofit, and they have a headquarters in DC, but they're actually made up of 6 regional nonprofits. They all have separate names: Communities Unlimited, Great Lakes Community Action Partnership. You can see them there. But together, they cover every state and all the U.S. territories. And they work in I guess the best thing to say is the rural space related to water and wastewater. So many of their staff, they probably have between the 6 regions, 400 or 500 staff. They operate in every state. Many of them are licensed water or wastewater operators, and we also have a team in each region that works on private wells. And so if you're in one of these states, let's say you're in Illinois, where I am, you can contact us, and we can get you in touch with the person for Great Lakes who manages a private well program, and they can set you up with a person in your state, whether it's Illinois or Wisconsin or wherever it might be. Like if you want to put on a webinar, you're a county health department or a local health district, and you want to put on or not a webinar, well, that too, but even an in-person event for the well owners in your area, they'd be glad to help with that. And so they're a great resource. They go out and do individual well assessments, which I'll speak to in a second. Really, they're in the game helping well owners. And in a few states where maybe the state doesn't have the resources for their state health department, they'll contact that RCAP region and ask them to help them with a problem well, or to go out and do an assessment to evaluate what can be done to help that homeowner. And so it's really a good program. And again, we're able to offer all of that for free because we're funded through the US EPA, and that supports this work. So I mentioned a well assessment. So we developed this. It's an 11-page tool. It's a fillable PDF. It's on our private well class webpage. But it's really meant for someone who has a fair amount of wherewithal, that understands private wells and well issues, like a driller or a co-op extension person or environmental health professional, to work with a well owner one-on-one, to basically do an assessment of their entire well and water system. And I'm just showing part of the first page, but it talks about, water use, geology, if there's a well log, if they've ever sampled. It's a site evaluation as well. I mean, are you storing things right next to the well? This, as crazy as it sounds, is your well in a basement or in your garage? Because we see that sometimes, even though they really shouldn't be. So it's an opportunity then for someone who has expertise to sit down with a homeowner and walk through. Do you use backflow devices on your outside spigots? All those things, so that they can ask questions. The homeowner can ask questions, and the professional person can evaluate where there's things you might be able to change to make it more safe to use your well. Or, we see crazy things like a Folgers can, an old, just a tin Folgers can, over top of a 6-inch well. And that is the case, that is the wellhead, instead of having a sanitary well cap. Well, anything can get in there, bugs, all that sort of stuff. So this tool was developed by a group of experts, private well experts, here at the U of I and from around the country, to provide a way to work with a well owner one-on-one and help them understand their well better, their situation, If there's a well log available, they'll find it. And now, it wasn't always the case, but now when they do these assessments, most of the time they can also offer a water test that they pay for. And so it's a pretty good deal for a homeowner who's interested in learning more about their well and their situation. Um, it's like a sanitary, so those of you know what a sanitary survey is, which is for public water systems. It's kind of a vulnerability assessment in that respect. It's a chance to educate homeowners with wells about their specific situation. And what I can tell you from, so at the State Water Survey here where we are, I've been here 38 years. We house the state's well logs. We get calls from homeowners in Illinois who have a lot of questions about different things. We have, with the logs, we have all the geology and understand where the vulnerable areas are, all that stuff. And what I can tell you is, I've probably visited 1,000 wells, and every one has something different, different kinds of pipe, different site assessment situation. Some of the things they're using for treatment, all those things can be different. And so it is very specific and unique almost every time you visit a homeowner with a well. It's also a chance to promote best practices. At the end of the assessment, there's a write-up that they do that basically tells you, here's what we recommend, here's where we see a risk. Also, here's some best practices. Here's why you should test every year for coliform nitrate and every 3 to 5 years for this list of inorganics and metals. All that sort of information. It also encourages more communication. Some well owners feel incorrectly that they can't call their county or local health district because they might tell them they can't use their water. There may be one or two local health districts out east that actually have that authority, but in over 99% of the country, that is not the case. And for instance, we work closely with our public health, our county public health departments in Illinois, and a county health department may suggest because your arsenic is 5 times the legal limit for a public water supply that you don't drink your water, but they can't tell you you can't. They can only recommend what's the best practice and try to convince you why it's a good idea not to do that or why you should have treatment. And so folks learn a lot from these things, from having these assessments done, even more about resources available in their local areas. And so I certainly recommend it for every homeowner with a well. They've done about 4,000 of these. I will say the one thing is, there's only so many that can be done because of the cost. Sometimes, again, like I said, they're requested because of a state or local agency that has a problem and they don't have the manpower, the bandwidth to do that. And so, and the developing partnership side, that's where the in-person classes come in. You can talk to someone, let's say in Kansas, and the person from MAP, the Midwest Assistance Program, will find a time, maybe find you a driller or another professional who can give a presentation. They can support your program and your local efforts by being a partner. And again, the assessments many times include sampling, and it's all free. Yeah, so we also have an on-site wastewater treatment system assessment. It's a fancy name for your septic system if you have a traditional tank and drain field, but there's a lot of other more advanced systems out there today. And so this is fairly new. RCAP is also doing some of these assessments as well out in the field. But for our role in the private well class, our interest in a septic system is as a source of contamination. We're not as much into, for the private well side, we have another program where we're using this more, which is called decentralizedwastewater.org. But we're interested in whether the septic system might be causing bacteria or nitrate or other issues for a homeowner with a well. Just want to mention it's available. Those are both on our website. For the private well assessment tool, we actually have a guide we've developed, which is pretty extensive, but we do not have a guide for this particular. This is pretty new. So a little bit about us, the Illinois State Water Survey. Every state has a geological survey and a natural history survey. Illinois formed the State Water Survey in 1895 because of cholera and typhoid outbreaks, and they wanted to learn more about what's going on with the quality of our water. And so from there, we've grown. This is a placard that's outside Noyes Lab on campus at the University of Illinois. which is our chemistry department. That's where this started. Now we have our own facilities on the south end of campus. We're a little over 120 people, I believe, full time, and we're part of a larger institute on campus called the Prairie Research Institute that houses all 5 of the scientific surveys. And so it's a really cool place to work from the standpoint of we house the state's well logs, we have state mandates, but we also get to do research. I've done a lot of work, for instance, looking at arsenic or looking at private well issues, and we're involved in several research projects looking at those issues, as well as doing things like the private well class where we're providing education and outreach. So it's honestly, it's a lot of fun. That's why I'm still here. So the water survey has been around forever. With that comes, especially the first organization in the state that's really looking just at water and water quality issues. So we have a lot of really cool stuff in our files. Like, for instance, this is from 1938. It's a chemist at the water survey. That's kind of what, if you look at that room, that's the way a chemistry lab looked in those days. You can see the Bunsen burner underneath there. This is a picture from, I believe, the 20s when we were sampling all the parks in the state. They used to have all these hand pumps that were available. Well, if you look at the very front edge of that wooden platform, there's a little tin cup upside down there that's supposed to be probably hanging on a wire. So anybody could come up, start pumping that, get a drink, rinse out the cup. Don't care who drank before you. Different world we lived in those days. Which these are outlawed. I believe in having these pumps. The problem is they sit with water standing in them, right? This kind of pump has a check valve every so often so that you can pull water up but it won't fall back down. And so those things get full of bacteria and biofilms, and they'll make you sick. And so at the time we were testing some of these, and we've tried, done way more than our due diligence to try to figure out what town this is. And so far, we've had no luck. And, a number of people looked into this because I would love to know. There's no documentation on that. These are on glass plate slides that existed. We have back to 1900, and there's no. We can't figure it out. It's that simple. This is the way wells were drilled. This is in Weldon, which is not too far from us here in Champaign-Urbana. In 1922. There's a steam engine off to the right that you can't see that's driving the train there, if you will. And these are well drillers putting in a well. There was a lot different process back then. A lot more went into it. A well might take 2 weeks, where today, some of the monitoring wells we put in where we're not trying to make them potable water, we might put in 2 a day. So yeah, it's pretty interesting how all the stuff has changed. Yeah, this is a modern rig, and Kickapoo Drilling Company is an Illinois driller, and you can see what it takes to put in a well, but it's a lot faster process. They're using clay and polymer grout or mud so that it keeps the hole open and they're not letting stuff get through. And once you put your well in there, then you seal it on the outside, the annulus, and we have well construction code that dictates what kind of pipe you can use, what kind of glue you can use, how it has to be grouted after the fact, all of those things, and a sanitary well cap, all so that it's protected from surface influence once it's been put in the ground. And so then the issue is like that well from 1922 that I don't think that was for public water supply for Weldon, Illinois. But that well still may be in existence, and somebody may be using it for their home supply. And back then, there was clearly no regulations, no materials tracking, no anything, no licensed driller. That's the other thing. In all states but 2, you have to be a licensed driller, and there's well construction code set up through the state. And so, and that's to protect all of us and our water supply. So here's really the things to remember. Private wells aren't regulated, and that should say probably after construction. Well over 90% of the country. There's some states who maybe do some testing. A few states require testing at property sale, New Jersey doing that the longest. but it's really up to you as a homeowner to make sure your water is safe to drink. Um, I'm like I mentioned, I've done a lot of arsenic research. Arsenic is colorless, odorless, and has no taste. So no matter how great your water tastes, no matter how clear it looks, you have no idea if you have arsenic in your drinking water from a private well unless you test it. And so everyone should test their well. And that's the bottom line here. And so like now it says the average person may pay $60 to $80 a month for their community water supply. I put this in here and I've changed this number so many times. I have a teenage daughter. Our water bill is always over $80 a month now, and which is frustrating as a father and the bill payer. But what I pay to our public water supply is what's spread out over all our residents and all our homes so that they can make sure that there's always water pressure, that the water has been tested and it's safe, and that there's someone managing the treatment plant that knows what they're doing so that the water that's coming out of my kitchen tap is safe to drink. There's always pressure and it's always there for me. Um, as a homeowner on a private well, you're responsible for all of those things. So it's not just testing, it's also making sure knowing the information about your well, what aquifer you're in, where your pump's set, how old your pump, um, you know, a lot of other issues that, what happens if all of a sudden in the middle of the night I don't have water? Why is that? I grew up on a farm on an old dug well, and our pump was at the surface. It wasn't a submersible pump. It was just, it was a suction pump. And harsh winters in Illinois, we had a little building. It's about 100 yards from our house. Um, if it was really cold and we didn't have enough propane in the propane tank that kept that little building warm, portable, we might have our pipes freeze and burst, or and not have water for 4 or 5 days. Uh, yeah, it's a responsibility, and the more remote you are, the more risk it is for those things. And so you really need to understand even what to do when there is some kind of emergency, like the power goes out. Uh, so many people have asked me, well, what do I do when my power goes out? Well, if you don't have a backup generator, then you're not going to be able to run your furnace, your freezer, your refrigerator, or your well in all likelihood. And so you need to figure all that in. We had an old generator that was a Honda motor that was basically bolted to a big piece of plywood with a frame that it took 2 people to carry. And we had to carry it out to our light pole and plug it in so that when our power went out, and this is in the 70s, okay, we would be able to run those things that were most important. Um, yeah, and it's still reality today for folks that live in very rural areas. If a line gets taken down because of an ice storm, if you're the last person on the line, it might be a week before they get to you. That's just the facts. And so what we try to do with the private well class is these things, and I've mentioned this again, I'm sure, but it's really about knowing where your water's coming from and how it gets into your kitchen tap. So how deep's your well? If your pump's in is submersible, what's the setting? Does it have a screen, or is it a bedrock well, or is it an old dug and bored well? Understanding those things really give you more information for when there's a problem, or understanding what your risk might be from surface contamination. And so you also need to know about naturally occurring contaminants. So, we have aquifers in Illinois that have arsenic. Out east, there's aquifers that have uranium or radium. There's all sorts of things, and I'll go over some examples of that. But it's about being a little inquisitive and asking the right questions and knowing who your local sources of information are. And we actually, our 10 lesson class, lesson 7 is actually just called How to Find Local Information. And it's really about who in your around the country locally would know things about your either your aquifer, your geology, your well, and why it's important for you to know who those folks are. Okay, so probably the most common questions we get are related to testing. Where do I collect it? What do I test for? How often? All that stuff. Is one sample enough? And when it gets down to the bottom here, what do I do with the results? That's a real problem for some people because it may mean you need to add treatment, and that's expensive. And so, we have people tell us they haven't tested because they wouldn't be able to add treatment anyway. They couldn't afford it. And that's just a reality for some people. And we need to figure out how to deal with all of that. That's kind of one of the things that we try to work with, find partners for them. Um, but there's a lot more need than there are those resources to go around. So anyway, I was getting back to the water quality here. Um, so the thing to understand is the water coming out of your well, if it's straight, it's groundwater. It's got the natural mineralogy and any naturally occurring contaminants and any other bacteria that may just exist in groundwater, which they do, like sulfate reducing bacteria or iron bacteria. They aren't necessarily harmful, but they can cause biofilms and other things. But all of that is your groundwater. Now, when you run it into your home, you might be running it through a softener, a filter. You might have lead pipes or galvanized pipes or copper pipes. There's all sorts of things that can change the water quality from what's coming from the aquifer to your kitchen tap. And I'll show you an example, I believe, in a minute. But um, our lab, we used to, so the State Water Survey, like I said, it's been here forever. Until 2008, we offered free water testing for any Illinois resident with a well. And that wasn't just nitrate and coliform, it was for inorganics, metals, all this stuff. So we were under the Illinois Department of Natural Resources back then. We were moved into the U of I, and this institute was formed, and all of that had to go away. We had to start charging just because of the way the rules are and cost recovery and not competing with private labs that are businesses and all those things get in the way. Um, and so, anyway, we always collected two sets of samples, but again, the homeowner wasn't paying the bill. One from an outside spigot, that's before any kind of treatment, and then a second one from the kitchen tap, which is basically what your drinking water would be. Because we use the outside spigot as, we collect the inside sample first if we were doing the sampling, or we tell homeowners to do that. And then we go out and let the water run from an outside spigot for 15 or 20 minutes to make sure the pump had kicked on and it's actually fresh groundwater. And then we collect the sample so we know what's the groundwater quality in those areas. And because of that, we have a ton of really good water quality information about the aquifers in Illinois that we no longer get, is the bottom line. We can't ask a homeowner to pay for two analyses. And in fact, January 1, 2024, our lab stopped providing private well samples, even for a fee, just because the volume's not there. But when you go to a lab, things you need to know, do you have lead pipes? And if you don't know, you need to find out. If house piping's from before 1986, Illinois has a distinction of being the last state in the country to outlaw lead pipes, which is in 1986. And so that's why we use that date, because it's likely that earlier than that you may have, it's more likely to have lead. It's a great material to use. Plumbers love it. And so these are things you need to understand going in, as far as also helping you decide what you should test for too. But when you call a lab or talk to a lab, they should be able to provide you detailed instructions, tell you why. We find that that's a real challenge for some labs, and so things are kind of changing there, which I'll get into in a minute. But what I tell homeowners is if you call a lab and they can't give you the information you need, or they don't have the expertise, if there's another lab available, I suggest they try them first. Now, we have a help center that's online as part of our private well class. Folks are always welcome to send their sample results, and I'm getting ahead of myself, I think, to us, but you should also send them to a qualified health professional, like an environmental health professional in your county or local health district too. So as far as where to sample, I've already brought this up, but the outside tap is representative of well water or natural groundwater, and kitchen tap is really your drinking water, and they can be very different. So here's an example of that. So this is a homeowner that's on a very large sand and gravel aquifer in central Illinois, which is what our city water supply uses as well. It's called the Mahomet Aquifer. And this is their outside spigot. So this is their natural groundwater. It's got sodiums at 20. The things that are highlighted here are important for the next two slides you're going to see. Sodium was at 25.9, turbidity is 29.8, color's 41, 48.1, and the pH is 802, and then hardness is 351. Most groundwater is hard. It usually contains a lot of iron and manganese, at least in Illinois, and so those things are always something to be aware of. And then, so they also have treatment. So they took a second sample that was after their filter and their softener, and so they're using sodium salt for their softener, which is the more common. It's cheaper than the alternative types. And so now their sodium went up to 198 milligrams per liter. Well, and I know we have a question from someone today about what happens when you're on a low sodium diet. Well, you shouldn't be using sodium salt in your softener if you have one. The alternative most people use is potassium salt instead of sodium. But you can see the turbidity, color, and the turbidity and color went way down, and that's because you filtered out a lot of things. Some of it's also oxidized and got caught in the filter. And then the hardness, the softener is doing its job, right? It went from 351 down to 68 on the bottom right there. So they also have an RO unit, a reverse osmosis treatment device, on their kitchen tap, and it's only that point of use. But when you add the RO, which it takes out most things, you can see that it's dropped everything to a less than sign almost. The sodium's down to 6.24, and all that stuff. But you've taken out all the buffering in the water that keeps the pH high, and so now the pH there is 6.23, which is below neutral. It means it's a little bit. It could be a little bit acidic or corrosive. Doesn't mean it is necessarily, but it's something to watch, especially if you're in an area where the water already has a low pH. Because the lower the pH and alkalinity, the more likely, and coupled with alkalinity, it could cause corrosion of pipes or corrosion of lead solder, some of those things. So it makes a difference, is the bottom line here. What kind of treatment you have, even if you're doing something like, let's say you have methane in your water, so it comes off as a gas. So a lot of times you put an aerator first, which is a separate tank with a vent on it. And then when the water comes up into that tank and it's at atmospheric pressure where the water in the ground's under more pressure, all the gas gets released and it gets vented off. Well, you're also exposing that water to air, and that's going to cause reactions, chemical reactions with some of the metals and stuff in the water that are dissolved, like iron and manganese. That's why you see the brown and the black staining from those things. So you're changing the chemistry every time you do anything with your water. And that's really the thing to understand, is that you can have these unintended consequences, like all of a sudden you're drinking water with almost 200 milligrams of sodium in it, which when I was preparing for this webinar, I looked up some of the health considerations, and I know for a very restrictive low sodium diet, it's about 500 milligrams a day. And so that's 2.5 glasses of water, basically. So it is important to understand all those things. As far as what to test for, I'll provide you with a list that we recommend, but it's for a national audience. So it doesn't have any of the particulars that you might have in your state or area, but it's also different depending on how deep your well is, where your water is coming from, are there known contaminants in the area. And so we always recommend that you can start with the list we give you, but a lot of the good labs have a private well list, if you will, and they test for a set of constituents. It's like 50 things. It might be 42 here and 51 there, but it's most of the things that you'd find typically in groundwater and well water. And it's not the more all the things in the news today, like hydrocarbons from diesel or from any kind of oil-based fuel, or PFAS, or some of those things. Those are more expensive, or pesticides. All that's more expensive, but this basic test should tell you whether you're at risk of these other things, just because if you find them in your well, it means that there's a pathway into your well from the surface, and you're not going to see some of these things if your well's really deep and it's well protected, that sort of thing. But you just need to ask your state well records folks, your health department, even a driller, They'll know if there's anything in the area. And then the point of sampling for coliform and nitrate, coliform bacteria and nitrate, isn't because those are actually harmful necessarily. Nitrate's harmful for babies. It causes blue baby syndrome. But if you have elevated nitrate or you find bacteria, coliform bacteria, those are near surface things. You don't find coliform bacteria deep in the soil or deep in the groundwater. And so if you do have those, it indicates that there's a pathway into your well. And so that's why we recommend you sample for those every year, because it suggests that there's a way for surface water to get into your well. Not necessarily that those two things are going to make you sick, because it's E. coli and fecal coliform that make you sick, not just straight coliform bacteria. So as far as examples, I've got 3 to show you. This is Rhode Island, or most of Rhode Island. I cut off a little bit of the bottom just to make this better. But all those little circles are where there used to be orchards. And for many, many, many years, arsenic was a big component of pesticides used in orchards to keep bugs off your peaches and everything else. And now they find that some of the shallow groundwater in those areas have arsenic contamination, and it's actually got into the groundwater and all that stuff. So they show all those on the state map, which, those are pretty big areas when you get down to it. And then there's that splotch in the middle with the 3 little pieces at the top. That's, well, I guess there's 4 on the bottom too. That is where there's natural occurring beryllium in the groundwater. And this is a perfect example of why you need to ask. Because I'd never, been at this 38 years, I'd never heard of beryllium being an issue for a health issue related to drinking water until we found this on their website. And it's regulated. So a community water supply, if they have to test for beryllium, and if they have it, they have to remove it down to a certain level through the Safe Drinking Water Act. But as a well owner, you have no idea. And I would never recommend testing the rest of the country for beryllium. So that's why you have to ask. And this is really the poster child for that, in my opinion. But it's a real thing. If you live in the central part of Rhode Island and you're on a well, you definitely need to test for beryllium. Some states also have like this resource from Massachusetts where you can just enter in your address, and they know their bedrock aquifers in some places contain either arsenic or uranium. And so you put your address in, they've already mapped all that, they've got a lot of water quality data. It'll tell you whether you're at risk of one or both of those things. And then they've also provided in the little window in the upper right other information you can use, where the uranium probability zones, arsenic uranium fact sheets, so you know what it means if you have those things in your water, as well as labs that they have available that are certified to test for those things. Pretty helpful if you live in Massachusetts. This is the states taking this on themselves. And, there are a number of states that are developing these tools or even better tools, like the state of Wisconsin. So Wisconsin has this viewer. It's called their Water Quality Viewer. And it was put together by Wisconsin Stephen Point, but it's mostly data from Wisconsin DNR, which regulates both private wells and public water supplies in Wisconsin. And so when you can, on the left there, I told it to search Winnebago County for arsenic. And what is provided then is a statistics report. I highlighted 25% of the samples were over 10, which the EPA sets a standard for public water supplies at 10 parts per billion. And so that's generally what we tell well owners. It's what your community needs to be considered safe based from EPA's work. And so that's what we would recommend then to a homeowner to be consistent and all that stuff. And if you look at the statistics, there's only 32 wells that are over 150, but one of those is 15,000. And so, and the story there is there's a deeper bedrock aquifer that their state legislature has made it legal to put a well in that unit, that geologic unit, because it's so high in arsenic. But when you look at the state as a whole here, you see a lot of gray. I think that's gray, which means 0 to 10 on average. And even these green counties, which if I have any of these colors wrong, I apologize. I'm colorblind. So it's just what it is. I see green for the 6 counties that have a little bit higher arsenic and gray for the others. So the green ones are 11 to 50 as an average. And this one you can see the average is 35.23 in this little summary report. But this looks pretty benign, right? I mean, it's not too bad. There's not a lot of arsenic on average, and in most counties, it's below 10 for an average. Um, because of that, though, they also have a second parameter that you can look at that is maximum arsenic. And that looks a heck of a lot different, which is the maximum value of arsenic they have in that county. Um, and so this time I highlighted Brown County, which is where Green Bay is. So we're just a little bit northeast of Winnebago, where we were before. Um, and these statistics, you really have to look at them because you look everywhere in red, it'd make you think, oh my gosh, I don't want to put a well there. Well, Brown County, only 3% of the samples were over 10. All the rest, 97%, are safe, considered safe. And so it's much more likely to have a well with low arsenic in Brown County than it is Winnebago County. And the maximum they found in Brown County is 810, but they're using the same scale, which is anything over 151 is red. And so this really stands out as you really have to pay attention when you're using some of these tools. But this is really a great resource just because of all the data that you have. And you can look at nitrate or coliform, or there's all kinds of things you can look at. I think you can even look, instead of the county level, you can look at the township level. In some of those cases, there's going to be no data when you start looking at a smaller scale. But there's just, you should know if this sort of information is available in your state. And there's more and more states that are starting to develop these tools. And that's kind of the message, I guess. So what we suggest is that you, as I mentioned, coliform and nitrate annually. Now, Penn State Extension has a really great private well program for the state of Pennsylvania, and they recommend 14 months. And I mention that just because it's actually, I'm debating if it's a great idea. I think it is. But if you sample the same time every year, depending, if you're, for instance, I grew up in an old Duggan board well. When it rained hard or water was cloudy, it was totally um, influenced by surface water. But more rain in the spring, you got snow in the winter, ground might be frozen for 4 or 5 months. And so by sampling every 14 months over a 6-year period, you sampled in every other month. And you may see some differences depending on the type of well you have because of that. And so it's actually a good idea. But if you do it like clockwork and sample every 14 months, most people sample once and then they don't sample again. I've seen things like, I just know growing up, we had a big riding mower and a big front yard, and I don't know how many posts in our yard I clipped or snapped or whatever. I just think of some high school kid on a riding mower and their well's right in the middle of the yard. I wonder how many times in its PVC, how many times that either the thing on the bottom with the blades on it is clipped that and maybe cracked it versus yeah. And so it's worth, things can happen. And so even sealed where the pipe joints come together, those can come apart. They can unscrew. It's not common, but someone didn't do a good job, or it's misthreaded. If it's a threaded set of pipes, you may have leakage into your well from near the surface, and that's going to be a problem. So then every 3 to 5 years, we recommend this set of inorganics and metals to give you a good feel for what's common in groundwater. Some things are harmful here, some aren't. Iron is not a health risk. Sulfate's not a health risk. pH is just good information to know about possible corrosion or how aggressive water might be. Um, and um, lead obviously is a big one to be worried about, as well as manganese and arsenic. So again, this is a starting list. Most labs that have a quote private well type of analysis they'll do for you have a lot more things on it. That's not a bad thing. Um, this basic set will at least allow you to evaluate the groundwater for where it sits as far as how reducing some of those things it might be. And so again, go to your local or state health department or a local health district and ask if there's anything else they would recommend. And every one of those departments has its own expertise. Some have none, and some have, a lot of expertise. And so it really depends. I mean, Wake County, North Carolina, it's urban mostly. It's Raleigh, but it also has a lot of private wells in the county. They have 2 groundwater professionals that work for the county, and so they have a ton of wherewithal. Whereas, in one of the more rural counties in Illinois, there may be no one that does anything but takes in the well logs from the drillers whenever they put in a well and signs off on a permit, and that's it. And they really have no well experience whatsoever. So you're going to run into, depending on where you live, both of those things. As far as when to test, obviously the things we just recommended, but also, anytime you've opened your well, you're giving it a chance to get bacteria in there. If you've had to shock chlorinate or disinfect your well, you should take a sample once that's all done to make sure it's now safe to drink. Sometimes shock chlorination does not solve the problem with one try. And I'll talk about that later. And then obviously, anytime there's kind of emergency response event, flood or fire, um, you know, there's a lot of sampling that went on in Texas and Florida in like 2017 after those 2 big hurricanes. This is El Paso County, Colorado. After a wildfire, that cap on the ground is flat now, but it's an aluminum cap, and it was probably 3 or 4 inches tall, um, and it's just been melted down. And you can see those wires; they're all melted. All the wires that are going into the well, it's dripping that plastic down into the well. In all likelihood, this well probably can't ever be used again, but I don't know the specific details. Gentleman I know there had sent us some pictures to use, and they're pretty powerful, though. They tell you what, you don't want that stuff in your well. So, and we've got a lot of materials on what to do when a fire does occur and all that stuff. But in the end, don't drink your water if there's any chance that something has occurred that doesn't make it safe anymore. As far as getting it analyzed, so every state accredits labs. Like in Illinois, that's the Illinois EPA. They accredit labs, certify labs for testing for public water supplies because they have to test every 3 months under the Safe Drinking Water Act. Again, that's for a public water supply. But many of those labs also do private well testing. And the thing to remember is that some states have programs for private well sampling. Most do not. But again, when you talk to a lab, they should be able to give you all the information you need. If they send you an ice pack, or if they're going to give you one when you pick up the bottles, whatever that might be, how to collect the sample, best practices, all that stuff. And you should ask questions until you're satisfied. Sometimes the lab can't give you all those answers, and that's frustrating. But and I'll talk about this a little more later. But an alternative is mytapscore.com, and quickly, we don't offer any testing anymore in Illinois through our state health department or through the water survey. So a homeowner in Illinois now needs to go to a private lab. And MyTapScore is kind of a middleman. They've developed relationships with about 200 labs around the country, and they do all the legwork. They do all the initial work. They do all the follow-up with the homeowner. So the lab just has to do the analysis. And so they ship you bottles with instructions. It includes a label for sending it back, and it's likely to go to a lab in your state or somewhere close. And because of the volume they do, they're able to offer that at a little bit lower cost. We find it's for the same constituents, it's pretty good deal. And so it's also easy to use because you don't have to go anywhere. They send it to you via UPS, I believe. And so that is an alternative. It's just basically you should consider it another private lab that's available to you. Is how I say that. But if you want to use a lab that's in your area, boy, excuse me. Again, the Safe Drinking Water Act, which the EPA administers, the U.S. EPA, requires certified labs, and so each state has developed their own list. And if you just Google EPA certified labs, the page is going to come up, and this second link, if you will, at the bottom is contact information for certification programs. And when you click on that, it tells you what the state has for each state, where the web page is that you can find information on labs. And the thing is now, because of overnight shipping and all that stuff, most states include labs that are not close to you. You know, there may be a lab in California that can ship anywhere in the country. So there may be 25 states that list this lab in California. That doesn't help you as a homeowner if you have to go pick it up, or if you don't want to pay shipping fees as well as everything else. But they are available that way. And then here's a list that's on that page. And so, like for instance, click on Indiana. They show you all the labs that they have that can do at least testing for a public water supply. And there are labs that won't test private well samples. And there's also labs that use, the methods for doing the analysis of every constituent are also regulated. So they have to use a specific method in the lab to do the analysis. There are other methods, some of them aren't as rigorous. And in some cases, the lab may use a less rigorous method for what they call a non-compliance sample, which is what the public water supply ones are. And you should ask that. Are you using the same method that's required for community water supplies or public water supplies? Because that's also a thing. As far as interpreting results, here's where, there are websites, and I'm going to show you one. It's pretty good. And a lot of information out there on what it means based on, what your results show. But we always recommend that you take it to a local health district, county health department, or state health department and get a qualified answer from someone. Just because you're dealing with your health here. And I will also tell you that you can take it to your doctor, but you're also going to run the same thing. Some are going to have a lot of wherewithal related to drinking water constituents, and some aren't going to have any. And so they may not be able to help you. So yeah, it's just, there's a lot to know, especially if you're a medical professional. And 83% of the country are on public water supplies where the water is being sampled regularly and treated to be safe. It's the 17% of you that are on private wells, just still 54 million people in the US that are kind of on your own. So it matters. So if you do find something that seems odd, or like say your county health department says, we've never had anyone come in with an arsenic result that high, then you might want to resample just to confirm it, because labs also make mistakes once in a while. And if you've tested for coliform and it's positive, then you should get an E. coli test done to make sure that it isn't that as well. But even coliform bacteria, like through the Safe Drinking Water Act, if you have a positive for coliform, a community has to chlorinate and show that they've got rid of it. And so what we would recommend with a coliform positive is that you boil your water until you can chlorinate your well. And shock chlorination is what people typically do. And I do have some information on that coming up here in a minute. I mentioned tools online. So the New Hampshire Department of Environmental Services developed this Be Well Informed guide back in like 2015 or 16. It's actually really cool. And it's set up so that anyone can use it. You don't have to be from New Hampshire. But if you click on the little green box at the bottom and say enter your water test results, it'll come up with this page. And it's handy because some labs report units one way or another way. Like for arsenic, I always say 10 parts per billion because it's easier to understand than 0.010 parts per million. And so you can put it in the units that are on your lab report. And there's a lot more here. I just did arsenic as an example because the standard is 10 micrograms per liter, right? So if you click on submit, it's going to come up with this red X. It's over 0.015, which is the drinking water contaminant limit for public water supply. And then they also have information here about types of treatment that remove arsenic, either a filter, absorptive media, or an RO unit. And that's really helpful. It even talks about that, when you're going to look for a treatment device to add to your home, make sure that it's been certified, like through the National Sanitation Foundation or the Water Quality Association or Underwriters Lab or can't remember now, that's a plumbers group that does certification testing. But you don't want to buy the cheapest treatment device. You want to buy one that you know will remove the contaminants you're trying to remove. And so it's important to understand that, like, if someone tries to sell you a different kind of device, that it, why isn't it one of these two? Uh, they should be able to tell you why, because sometimes they may be selling more than you need. If you go further down the page, it's just got more information and about the certification side. NSF ANSI Standard 53 for absorptive media and ANSI NSF ANSI Standard 58 for RO. And you want to have that certification on any device you purchase. And so tooting our own horn here, we held the first private well conference for professionals we ever had in 2017, and I asked New Hampshire to come and talk about this. And so many states were interested in getting the code so they could develop their own, that the EPA stepped in and worked with ECOS, the Environmental Council of the States, and now ECOS has set up this page, and this is the link. We can send it to you. You can email us. But all of these states now are involved with this, and they're pushing to try to get all the states to do it. And the reason it's the same, the guts of this are the same, how it calculates things, all that stuff. But a specific state may have different rules, or may, there's a few states that regulate arsenic down to 5, for instance, instead of 10. They're required to go to 10 federally, so they can't be any less or any more than that. But if a state wants to regulate their water supplies to a lower value than the federal government requires, they're allowed to do that. And so there are a couple states, as I mentioned, that have arsenic at 5, and that's what every public water supply in the state has to do. And so those states would want to give specific guidance. And so when you pick a state on this and you go there then and run through it, it's going to give you, like for North Carolina, it's going to give you specific information for North Carolina and not New Hampshire's. And so this list is growing. A few years ago, there were only like 8 of these states, and now there's 11 or 12, I think. Plus, I mentioned Wake County, North Carolina. They have enough wherewithal and are quote in the game that they petitioned and been allowed to also have. You can select them if you're in Wake County, and then you'll see Wake County specific information, like contact information for people and things like that. So it's pretty cool. But any of us, even if you're, Illinois is not listed here, if you're in Illinois, you can go here and use, I would use New Hampshire's, but or you can go to New Hampshire's webpage. They still have theirs up, and you can learn more about what your risks might be, depending on what your results are. So that said, when you're using these tools, or I know Extension has a few tools like this, some of the state extension offices, they aren't as robust as the Be Well Informed tool, but they still provide you some results. They're really a guide for typical water. You should still take your sample results to someone who's qualified to give you an answer. And again, in 99% of the country, they can't use that against you. You can always ask them first, what are the rules in my county or my local health district? Do you have the capability of condemning my well? And everyone but 2 in the country, I think, are going to say no, as far as I know. And so, again, they can't tell you to stop drinking your water, but they certainly may recommend it. A good example of that is we sampled a home in McLean County, Illinois, and they had 7 kids, and their arsenic level was 150 parts per billion, which is 15 times the recommended health standard. And so, we're not a regulatory agency. I was doing this for a research project. And so I asked them if the McLean County Health Department could call them, but they had no authority to stop them from drinking it. They should learn more about what it means to have water with that high of arsenic. And they said yes. So I sent McLean County an email with their information, and I stepped out of the way and let the health professionals do what they do. But again, it's 7 kids. It's pretty short-sighted to me to not do something about your well water just because maybe grandpa lived here until he was 85 and didn't get sick. Because we hear that all the time, and I'm sure anybody else who works with well owners has too. And again, we're always glad to look at your test results, but in addition to your health department, not instead of. And so, we have a help center. We have people send us their results, and we try to get them to the right place and evaluate what we see. We do know a lot about water quality related to what's in drinking water. But at the same time, many times when those come our way and it ends up at me, I'm calling someone like, the Minnesota Health Department, which I know has a lot of wherewithal to get information. Like, there's folks out there who will try. This is a totally other topic, but there's folks out there who may try to sell you a point of entry unit, like an RO unit, to remove arsenic instead of a point of use, which instead of just treating water you're going to drink at the kitchen sink, they try to sell you a unit that's much larger and it's at the entry into your home. And arsenic is not a risk typically, what we find in the United States. That 15,000 one from Wisconsin, not included. For any other risk, dermal, inhalation, or anything else, it's really a drinking water risk. And so you don't need whole house RO to remove arsenic, even if it's 250 or 300 parts per billion, because it's not a risk dermally. And that's, I'm not saying that. Minnesota Department of Health is saying that. So I use those folks to make sure that the information we're giving people is from a health professional and it's, correct. Uh, yeah. So shock chlorination, I mentioned that earlier. So when you have bacteria in your well, one of the things that's assumed is that it wasn't always there, and that somehow you had water, it got into your system, and now it's growing in there, and so you can shock chlorinate your system, and it'll kill the bacteria, and then you should be good to go. And so we looked at probably over 70 different documents that are out there from extension, vendors, and health departments, and you name it, on how to shock chlorinate your well. And uh, the best one, in my opinion, is this Minnesota Department of Health Well and Water System Disinfection for Private Wells. So we list this on our website under the resources for lesson 10, which is about treatment. And it explains everything about what you need to do to disinfect your well, because you got to mix it in the well, and then when you have this chlorinated water, you can smell the chlorine. Then you have to run it through all your pipes, and at every tap, every shower, every toilet, anywhere where water can come out, you should smell chlorine. And you do that before you go to bed. You let it sit overnight, and in theory, that chlorine in the water has a chance then to react with any bacteria that's on a pipe wall or a biofilm or whatever, and it'll kill it. And so this procedure is what I consider one of the most sound for that. And so, it talks about how to mix it, depending on the size of your well, how much water's in your well, the fact that it can, again, you have to mix it in your well first. So you run it through a hose and you're recycling it until it's all mixed. And then even things about what devices you should leave hooked up, which devices you better not have hooked up when you're running this chlorine through it. And so if you go to the privatewellclass.org webpage under for well owners, that drop down, one of them is class resources. And this is at the very bottom of the page for lesson 10. And it says well and water system disinfection for private wells. It's dated, it's from 2012, but funny story, they tried, the Department of Health hired a marketing firm to look at their information, and they decided that it was too long. It's like 8 pages. And so they went in and made it like a 3-page document, and it doesn't have half the information a well owner needs compared to what this other one does. And I was at a meeting, and I was talking about that issue, and a guy from Minnesota who is in their private well program, he works for the state, came up to me and said, we told them that they couldn't change this and it was much less helpful, and they did it anyway. And so we still host the old one that is actually useful, much more useful, I should say. Not that the other one isn't, for homeowners. Because the whole thing is now no one can pay attention for more than 40 seconds, and no one's going to read more than half a page, blah, blah, blah. If you own a private well and you have a bacteria problem, reading 8 pages, I'm sure most of you, hopefully all of you would agree, it's just not a big deal. It's your safety and your public health, and you're trying to figure out what's going on. And so other things here, though, related to shock chlorination. Um, a lot of private wells, because they don't have any kind of disinfection. It's natural groundwater that has natural bacteria, which, most of those are totally harmless. But with that and everything that's in natural groundwater, your pipes can grow biofilms, which is, this greenish whatever layers that can house any kind of bacteria or whatever. And if it's thick enough, when you chlorinate, you might kill just the upper layer of that, but there may be more underneath, and it might take 2 or 3 times. And so when I said earlier that after you shock chlorinate, you should test. If you test and you still have bacteria, that might be why. And then we would recommend that you chlorinate at least a couple more times before you give up, if you would. The other thing, though, is it could be something else, like it could be a continuous source. So the best example of that would be your septic system. If for some reason your septic, the discharge, the effluent out of your septic drain field is making its way back into your well, then no matter what you do, you're always going to have more water coming in that's got bacteria in it. And so the only way really to treat, there's only 2 ways. One is to go put your well somewhere else and put in a new well. The other would be to add continuous disinfection, which we would recommend chlorine, continuous chlorination. Um, so that you're killing any bacteria that come into your water. That's what a community water supply does. Any town that's on a surface water system, that water's full of bacteria, right? It's a lake, right? So Chicago, Illinois, 6 million people, they're on a lake. They chlorinate the heck out of their water all the time, and that's what they serve their residents, so that it's safe and it's got rid of any of those pathogens that might be in it. And so it's no different for a homeowner. You can't treat it is the thing. So there's also an issue because chlorine isn't effective when the pH is over 8, when the water is over 8. And it's, I don't know the chemical reaction offhand, but basically its disinfection properties go way down. And yeah, if you have a high pH groundwater, then chlorine may not, you may need to find an alternative. And, there are alternatives out there. They may require a professional to do. Hydrogen peroxide is gaining some popularity. You can install a UV unit, but I will also say that if you install UV, it works, but you have to filter the water first so there's no turbidity so that the UV light can go all the way through the water. And you also have to do something to get rid of any biofilms that might be past your UV unit. So chlorine, when you put chlorine in your water, it runs through all your pipes and out the tap too, right? And unless it's all been eaten up. But a UV unit is only treating at the unit. And so anything that's past that, closer to your kitchen sink, if it is the source of any bacteria because of biofilms, for instance, then it's still going to be an issue until you get your pipes cleaned. And that may require even mechanical cleaning of some sort. And if you run into those situations, I wish I had a better solution because it's probably expensive, but it's just, it's bad luck. It's part of being a well owner. Yeah, and there's folks out there who can, drilling companies or contractors who can help with all that. So, and there might be other things in the water that react with chlorine. Chlorine's an oxidant, so it oxidizes metals, things like that. And so it could be that you're using this dose that's recommended even in the Michigan thing, but it's all getting eaten up before it can actually be really effective. And so, the way to know is whenever you turn on the tap, if you don't smell chlorine, then there's no chlorine in the water, and you may have to use a higher dose. So those are all the caveats, if you will, to shock chlorination. Yeah, and many times it just works, but there's certainly cases where it doesn't, and you just need to be aware. So the other things we worry about are like poor well construction. So every state except 2 now have well construction code, and they all should. Illinois passed their code in 1968. New York in 2000, I think. I mean, that's kind of the extreme ends, but there's still a couple that don't. But even so, even in Illinois, where we passed this law in 1968, any well that was already in existence was just grandfathered in. So, like the well I grew up on, my grandpa hand dug in 1933, and as I mentioned, it was always contaminated because it had a direct conduit from surface water. So every time it rained, it was in a pasture with livestock. Um, some people say that explains a lot, and but we still have wells also in pits, and that was done because in a cold climate, if you didn't have your well below ground, your pipes would freeze. And now there's a pitless adapter that makes that a moot point. And but those pits can fill with water during a heavy rainstorm, and then it gets in through the cap, and it can contaminate your well. And then we still have all these shallow hand dug wells. Like I said, the one I grew up on was 14 foot deep. It's still in use today. Um, shouldn't be. And so those things, that poor construction is probably, to me, poor construction and just the sometimes lack of knowledge that well owners have about taking care of the well are the two biggest problems we have. It's not flooding, it's not lead, it's not PFAS today, whatever the new flavor of the year is or whatever. It's those two things. If we could bring all the wells up to code or have wells that are safe from surface contamination and educate our well owners enough to know how to take care of them, I think we'd solve 90–95% of the problems we have with folks getting sick from drinking well water. And not only is it a health risk, it's also a safety hazard. For example, the Washington State Department of Ecology is the state agency that regulates well drillers and well construction in Washington State. And for a while, they had a blog where they were putting some of this information up. There's an old piece of plywood over the top of this well. You can see, I'm talking about the one on the left, but you can see this is in a little building, and you can see the little funnel there. It was probably to put oil in the pump, and the gray stuff is probably insulation that's either rotted or been eaten on by rats. And so all this is a bad situation regardless. But then the plywood got old. It's got moisture on the bottom side all the time because there's a well down there. And the woman had probably walked over that many times. Each time it broke, she fell, and it killed her. In this other picture, Don was in Southern Illinois researching his ancestry, and I met him at just by coincidence, and he had this picture. Um, it's an old stone well that someone put a concrete tile for the first 4 to 6 feet there, but it only sticks up above ground maybe a foot. And so somebody's goat managed to find their way over there, and it was open, wide open. And yeah, it's pretty disgusting. That's the point. You don't know what's going to be in a well, what's going to fall in. Um, that's why they're supposed to be properly sealed at the surface, and nothing can get in, even bugs. That's how they should be. So what do? You should bring it up to code if you can, or put it in a new well. If it's in a pit, extend the pipe up to land surface and then fill all that in with a pitless adapter, which basically runs your water line horizontally to your house below the freeze line. And there's a lot of people locally who can give you some advice about what's the best approach depending on the type of well you have. And in some cases it may just be, well, we really feel like you need to just get a different well. Like this well that's on this picture, that's a well we sampled for a research project, but there's a field that had, it's mostly corn and soybeans. It wasn't that year, just upgrading of it. This is a cattle pasture, and they've got 2x8s and 2x10s with pieces of tin and concrete blocks and rocks holding that all down. Snakes, rats, you name it, can get in there. And in addition, the reason those posts look so funky is because the cattle in that pasture use those as scratching posts. So they're right next to the well, scratching and doing their business, and then that's all seeping right down into the well. Just, you can't make that stuff up. And it's so common in rural areas, unfortunately. And the same with abandoned wells. Like I said, well logs weren't required until at least the 60s. In most states, it was between the 60s and 80s. A few states it's later than that. And so every well that was already in existence, there's no log for it. My well that I grew up on from 1933 is there's no log in our files. But they're a safety hazard. People forget about them being there. They tear down the old farmhouse and build this nice fancy new home and a new well, and this old well's still sitting there. We had a person about an hour south of us contact us and said she had this hole in her yard and that she was worried. She'd been mowing with a riding mower and it kind of, it kind of spooked her or whatever. And she said, now when I look down there, it's like there's this big hole. So one of my colleagues and I went down there with a downhole camera, and it's an old, it's just an old dug well in the front yard. The fact that she didn't fall in with her riding mower is a miracle. But it was only like 17 feet deep and it had water in it. Um, but that house was moved there in 1916. She had all this history. And so, no one had any idea now that there was actually a well there. And yeah, so she was very fortunate to not have gotten hurt or killed. It's been there just waiting for somebody to fall in for years and years. So, yeah, enough said there. Here's just some examples. Somebody go down the well to get somebody else out. Um, there's a moose in an old well. I'm sure that was fun to get out. And then for those of you that are old enough to remember, back in the early 90s, there was a young lady, 18 months old. It's the third newspaper clipping down on this list. She was only 18 months old and she fell in a well. And it was covered live on CNN. Her name was Jessica McClure. And, she sang. I remember I remember when this happened. And it had the whole nation kind of glued to their TV to watch this. It took them, I don't remember how long, almost a day or maybe more. Well, that's her today, and she has three kids, and everything's hunky dory. But the other three clippings are all from people who, well, two of them people died. One in Sangamon County, Illinois, and one up by Chicago, Illinois. And then it happens more than you think. It's just if you're on a property that may have an old well like that, or you're not sure what it is, but it's got a concrete slab over it, fill it in. Don't take any chances with all that. So a little bit about our class before we get to the questions. Again, this isn't the class. These webinars are meant to support our 10-lesson class. So with our 10-lesson class, it's self-paced, meaning that you sign up with your name and email address and what state you live in, and that's really just to count beans for our funders, right? To say that, yes, we're covering the whole country. It'll send you a PDF as an attachment on your email once a week for 10 weeks. You're on your own to read it. If you have questions, you can email us or call us. That's why we have a help center. But it's really up to you. It's giving you a chance to learn a lot more about your well. And we're here to support you if there's things that you don't understand or you don't know what they mean or whatever it might be. And so if you go to privatewellclass.org, you'll see all that. And then we also, again, have a help center, which I'll talk about in a second here. And so this is our front page. And so usually people come here, they're looking. It's funny because in my entire career, I get calls from well owners when they have a problem. Nobody's calling me in the state of Illinois who has a well proactively to say, hey, how can I learn more about my well, right? They're calling because, hey, my pump might have burned up, or I'm not sure what the smell is in my water, or whatever it might be. Well, that's why. So if you have questions, we have a help center. You click on that link, and I'll show you that in a little bit where that leads. And then below that, it's like, are you ready to learn more? You can enroll in our class. You click on that button, it takes you to this page. And again, it's, all the things that it's really like Well Owner 101. It's meant to help you understand why it's important to do the things we recommend as far as testing and all that stuff. So you click on enroll in class, and it brings you to this little forum page. We also work with professionals in both private wells and on-site systems or decentralized systems like septic tanks. And so we have a newsletter for that. If you're just a well owner, you really don't need to sign up for those other things, just the information for private well users. But when you sign up with this first, last name, email address, and location, which is a state drop down, then you'll start getting that information from us. It's all free. We don't follow up and say, hey, why haven't you done this or any of those things. It's really, you need to have some interest and understand that, we're putting this stuff here to help you and all that stuff. And along with that, under for well users, there's a supplemental class resources. I mentioned that lesson 10. I showed that already. If you scroll down this page, these are just things that if you're interested in learning more about groundwater, how wells get contaminated, all those things. These are some resources we put together um, to help you, learn more about it. Raymond Lyle. These were written in there, one in 88 and one in 92 at Cornell University. Very well written, basic information that helps you understand what aquifers and groundwater actually are. It's not an underground river, all those sorts of things. How they get it, they're really well written. And so they really stood the test of time, in my opinion, and that's why we still link to them. And so then we also do webinars like today. So we have a button at the top, free webinars. This is what that page looks like today. And so on the left at the bottom is today's webinar. Next month it's on WellCare 101. I think after that we have a different one, but those are the only two we have actually set up in our system. But we'll have the rest set up fairly quickly for the next two or 3 months. But you can click on that and register, and that's how you get here. And then further, if you click on today's webinar, it takes you to a page that's just about today, and you can see the first webinar we did on this topic was in September of 2015. Everyone's recorded, everyone's on YouTube. You can go look at all of them. That's pretty simple. And again, so some of the material, it's updated, but some of the material is very similar. And so you wouldn't watch the entire thing, you just go to the questions at the end, which a lot of times is pretty cool. And then further down the webinars page, we link to some webinars we've only done once or twice or a few times. And for instance, for lead, the issues surrounding lead haven't changed. What we know, we knew in 2016 and 2018. We actually had a researcher then from Virginia Tech lead the 2018 webinar. She did a lot of work looking at lead in homes with private wells in Virginia and North Carolina. And so we asked her to do this presentation. And so you can watch that, and it really gives you all the basic information you need. I mean, if you're in a house that's more than 40 years old, then you just need to know whether you have lead or galvanized or copper pipes with lead solder. That's really the bottom line. We also have a series of these training videos, what you should know about a shared well. It's amazing to me how many people actually share a well with somebody else. And there's a lot of different scenarios for that. But a lot of times we'll get a call and they're having problems because the well's on one person's property and the other person doesn't want to pay for the burnout pump or their share. And maybe there's 3 or 4 people on the well. Or somebody sells their home and it's the home that had the well on it. And now the new person is like, wait a second, I'm not sharing my well with everybody. And there's nothing in writing. There's nothing to protect. And so it's really just a set of, it's only 2 minutes and 31 seconds long. And it's really just quickly about what you need to know and how you can protect yourself if you're on a shared well. And we also have information on our help center there too. And then this one, we always show, how does my pressure tank work? And there's another one, I can't remember the title now, but it's basically, it's also about pressure tanks. And now the technology is changing there, but 10 years ago, most tanks were larger in your basement or in an area where you had to keep pressure. Most people don't know how those work. These two, the webinar on basically problems with pressure tanks, it's had like 450,000 views or something. It's amazing how many people have watched that or went to that page. And it tells us that there isn't a lot of information out there about pressure tanks and the issues with them. And this kind of goes through all that. And again, this is only 4 minutes long. So it's just meant to be kind of a way to get familiar with the topics and solve the easy problems that you wouldn't normally so you wouldn't need to get a contractor or something like that. We have a podcast called Tap Talk, the Drinking Water in Rural America podcast. It's actually the URL is drinkingwaterpodcast.org, but we interview professionals from around the country. The folks on the bottom left, they're both with the state of Iowa. And, Iowa has a grants to counties program. It's not called that anymore, but basically their state legislature provides funds to their counties so they can cost share well abandonment, well construction if it's in a vulnerable area, even testing. And so Iowans have an opportunity maybe to get their water tested at half price because of this program. And so we interviewed them um, about that program. It's been around since 1986. I wish every state had one. They're the only ones that do. Yeah, and so there's a variety of topics that are related to wells. We also interview folks on the public water side, dealing with water and wastewater operators. It's pretty useful. It's really usually about a specific topic. I like Vanessa Demuth down at the bottom. She's in Dakota County, Minnesota, and they're sort of wealthy because they have several landfills. They're on the south side of Minneapolis, St. Paul, and they use those dollars then to do all kinds of additional testing. And they're looking at things like PFAS, where waste has been applied to fields and other ag chemicals, and they just have a research program of their own, which is unusual at the county level. So it's a really interesting conversation. I mentioned our help center. So Sally Dolan and Sarah Manderbach manage this. Sally developed a lot of it, and she's an EHP. But you click on that, and it takes you to this page where you can even in the middle of the night you can ask our chat bot, which is only going to answer with things that we've provided. So it doesn't search the web for some crazy answer that doesn't exist. It's only using our material to come up with an answer to any question you might have. So you can call us, you can email us, you can search by topic, and these boxes that say, like in the middle it says water quality, there's 47 articles that we've written that are about water quality. And an article is basically the title is the question, and the body of the article is the answer. And what this has done for us is that we don't get calls anymore from people who say, what should I test for? They're going through these articles and they're figuring that out on their own and what we recommend. And we get much harder questions. Like the poster child for that is a guy called and asked, he just put a new galvanized drop pipe on his well pump, and how long before that's seasoned enough that it stops releasing cadmium? Because cadmium is part of the plating process for galvanization. Luckily I know a lot of folks because I had to find out a lot about that even to understand what the issue was. But that's what he'd been told. It'll take a while for that to season. You're going to see cadmium in your water, which isn't good. And so we gave him an answer. But that takes more of our time too. It's a lot easier to tell folks some of the basics, like how to shot chlorinate, go to this article kind of thing. So yeah, but it's really useful, and it's growing. When we first started in April of 24, maybe a few thousand people came the first couple months. Well, now it's the people that actually come and view the articles is over 50,000 a month, and so, which is a great thing. It means that we're doing some good, and people are can relate to our advice, hopefully. So I mentioned you can just search by topic. So if you just type in flood, there's more if you go down, but top 4 here is my well safe after a flood. How can I protect my well from severe weather and lightning? All these things are related. And so flood was a keyword. So you can go to any of these articles and find information. Some of these go to those videos that we have, like the one on shared wells, for instance, depending on what you type in. So pretty useful. Yeah, if I click on the top one, this is my well safe after a flood. It's a short video we put together, and then the text of it's in this article. I showed this slide before, but I always show it at the end again because hopefully you have a better appreciation or understanding on why these things are important. If your well's 14 feet deep, then you understand that you're very likely to have surface contamination. But you could also have a well that's 600 feet deep and be just as susceptible to surface contamination. And in that case, I'm referring to a bedrock well where bedrock's near the surface. And if the well was put in before well construction code that required at least 50 feet of casing, you might have 20 feet of casing. And after that, it's an open hole. You drill through rock, the rock serves as your casing, and you want to leave it open so that any fractures you encounter where they might be water can contribute to the well. And so I ran into this in New York, in upstate New York, um, north of Syracuse, where there's all these deep wells that have 20, 16, 25 feet of casing, that's solid pipe, but after that it's open. And so water that can get down to that 25 feet where bedrock is at the surface and it's fractured, um, those wells aren't safe just because they're so deep. So well depth alone doesn't tell you anything. You need to know the type of well, how much casing there is, all those things. And yeah, hopefully going through those 10 lessons will help you when you do have an issue. You'll know who to contact locally, and you'll know what questions to ask, or you may actually be able to solve your issue on your own. And we've had a number of people contact us and say, I'm so glad I went through your class. When this came up a year ago, I would have had to call a contractor and spend $500 to fix this, and I was able to do it myself. And our goal isn't to turn you into a contractor, but it's to help you understand if this goes wrong, maybe this is why. And some people have the wherewithal to deal with that, and some don't. And then lastly, again, obviously sample your well. And this is our goal. It's really simple. The way I look at it is you run into well owners are from every demographic. They're college educated. They're maybe have a GED. They are wealthy. They're maybe very low income. They're very rural. They may be in a very urban area. Well owners really are every demographic, which makes them hard to target for outreach and get information to because they don't fit in any group, if you will. And so what we want to do is raise the level of knowledge of every well owner from, it's wherever it is. If it's at my chin, bring it up to my nose kind of thing. And to do that, if you go through the class, hopefully you have a better understanding of why your well is important for your public health and safety, and why you really need to understand how it works, because when you have a problem, understanding that process will make it a lot easier for you. And then what things can you do to help protect you and your family from risk, and specifically contaminant risk. I was just at a meeting where an oncologist talked about a study that was done where they didn't know there was arsenic contamination and for many years, and it was getting into this river, and the river was a water supply for a town. And so, and this wasn't the United States, but anyway, now, 50 years later, they have this huge cluster of cancer, bladder cancer, that's occurring. And they went back and they were able to work with all the folks that have gotten bladder cancer to learn, like, when did they first move to this community? Did they drink it as kids? All this stuff. And it shows a 20 to 40-year lag in when they drank water with high arsenic to when they actually got bladder cancer. So you may think, well, nobody's gotten sick yet, but you may already be drinking water that is doing something in your body that 25 years from now, all of a sudden you're going to show up with cancer, and wonder where it came from. So you can't. It's not an immediate thing. It's it's something you have to be diligent about, especially for your kids, your whole life. And so, and I don't know a better way to say it, because yeah, it kind of puts a pit in your stomach whenever you realize that. When I think about all the things I did as a kid, my dad would hand me a sprayer to spray around our buildings out on the farm, right? And those were, quote, real chemicals back then. This is in the 70s. No mask, no gloves, no nothing. And you realize now that that was really stupid. So, uh, if yeah, that's as dark as I'm going to get about all that. But it's really important to understand and make sure you're doing everything you can to protect your health, because you don't know when it might come back to bite you. So we did have a number of questions, which I'm going to answer. I don't know, 8 or 9 of those, I guess. We got a lot more than that. And again, Katie is also taking questions through our chat thing on your GoToWebinar window. And so get those in if you have them. We'll go through the questions that I answered in advance first, and then we'll go to that last. And so the last thing here, yeah, all of our past webinars have questions like the ones we're going to answer today, but many of them may be different. And so they're really worth going and watching if you're really interested in learning more about other questions folks have related to their wells or solutions, or, like no one asked a question about PFAS today, but on several of our webinars, we have a number of questions that were about PFAS and we answered them. And so it's worth checking out. That's all I can say. So first question, what does a well owner do when a water test is out of reach for seniors on a fixed income? So first thing I would do is contact your local health department or health district and see if they have any programs or they know of any programs that might be able to assist you in paying for that. I mentioned Iowa earlier. Iowa, there's a county program that can help. Here in New Mexico, they'll provide a free water test once if you'll register your septic system in their state database. That's the carrot. It's important to know where those all are because they're a source of contamination, right? And then the USDA has they have a loan program that's more spoke about in the private well world for low income folks, but they also have a program. If you call your state USDA office, if your income level is really low enough that you can use it for a lot of different things, water testing, replacing your windows. I mean, it's a whole laundry list. It's meant to help a disadvantaged homeowner. So, or even adding treatment. And I don't know a lot about that program because it's not specific to wells and we don't implement any of that. But your state office, USDA, can let you know. It's got really restrictive income levels, though. At least currently, I believe it's either I think it's 60% of the poverty level in an area, local area, and so that really eliminates most people, to be honest. But for some people, that may be just what you need. And then the last thing I mentioned, RCAP. Well, you can request a well assessment from someone in your region, depending on what state you're in, and most of the time that also includes a water test. And I will say that they do get a lot of requests, and so we're a small staff in each of those regions doing that work, and they have a number they need to do each year, and that's really the funding they have to do those free. So it may be that they put you on a waiting list, and it may be a year or two before they actually can do your assessment. But it's worth checking as another option. And I work with all those folks. They're all great people. They have seen hundreds of wells. Um, they can provide, a lot of good advice. And it's just spending an hour or two with them um, at your place, really, so they can take a look at your well. And again, it's all free. So, and there aren't a lot of other options. It's just, but unless you check, you don't know. We did a funding webinar in like 2022, and one of the things that we went out and looked for were like sanitary districts or watershed districts that might have some kind of program for the folks that are in their district, either for source water protection type things where they want to abandon wells, or whether offer testing, or it might be. And we came up with a bunch, um, totally local areas all over the country, but you don't know until you ask. And so it's worth spending some time trying to see if there might be a program in your area, depending on where you're at. I'm gonna take a drink. Hang on. Okay. Um, I am in a semi-rural area with numerous industrial facilities being built. Does this affect my well water safety? So I said there's a lot of ifs here. If the well is properly constructed and sealed, the annulus is sealed and it's got a sanitary cap and has plenty of casing, all that stuff. And if the geology is protective of infiltration, if you're down along a river where it's all sandy, everything's going to infiltrate. If you're in an area where there's 100 feet of clay before you get to any source water aquifer, clay is like is an aquitard, it's called, or aquaclude, doesn't let water through very freely, so infiltration is really slow. and it's likely that whatever contaminant there might be has been treated in some way by bacteria and other things in the soil. And if your state has a robust enough program that for these types of facilities that could cause contamination, they have to put in monitoring wells, they have to make sure it doesn't move off site, all that stuff, um, then it would probably be okay. And so, I'm in Illinois. I can look out my window and see farm fields. And so what I tell well owners here is if your well's properly constructed and you're in one of the deeper aquifers, and I mean by deep, maybe it's only 100 feet, but there's 50 feet of clay on top of that, then as long as your well's properly constructed and nothing can run down the annulus, which is the outside, when you drill a well, you have a borehole, and let's say you drill a 6.5-inch hole and you put in a 5-inch casing. Well, that inch and a half, 3/4 of an inch all the way around, you fill in with clay or cement so that nothing can run down the outside of the casing down to where your screen is. It's a sand and gravel well, which it would be here. And so as long as those things that it's properly constructed, so if it's cased and grouted like it's supposed to be, then you shouldn't have any surface water infiltration. And as far as the aquifer you're using for supplying your water, if the geology is such, as I mentioned, the clay, low permeability material, if there's enough of that between the surface and where your water is coming from, the aquifer where your well is getting its water, then it shouldn't reach it. And so even if you're in an area where they're applying pesticides within 20 feet of your well, if those things are in fact the case, you'll never see that pesticide down in the aquifer or in your well. And we know that from testing. One of the areas where we still see our nitrate at like background levels. I mean, we have so much nitrate applied in Illinois, right? Most places are above a background of say 3 parts per million. Is a very rural county that's completely agriculture, but it's an area that has 150 feet of clay at the surface, and so water can't. It takes forever for it to get down there, hundreds and hundreds or maybe thousands of years. So, and lastly, the industrial facility should be monitoring their groundwater for contaminants if they're in a facility that actually creates those kind of contaminants. And that's the other thing I guess I could have made more clear. Most states then have requirements if there's any potential hazard, just from lessons learned where that wasn't done in the past, so that they have to monitor like at the perimeter of their property to make sure that nothing is moving off site if there is anything, or that and they the way they build these buildings today are have redundancy to protect from anything actually getting out on the ground and infiltrating in to the natural system. And so you just need to ask those questions. Yeah, and it's important to know what kind of industrial facility they are. Some maybe have no risk, and some maybe have a ton of risk just because of what they're using in their processes and stuff. So, and there's another question about biodiesel near where they were, and I would say really it's the same advice, except you asked about testing, and hydrocarbons, are an organic, and so there are specific tests labs have just to test for those things. And that generally comes up when someone had a buried underground storage tank for their diesel on their farm, and that hasn't been used in 30 years, and they go to dig it up or to move or even look in it, and they realize that it's all rusted through and there's nothing left. And so whatever is in that tank has got into the shallow groundwater. And so you test to see if any of that has moved into where it can affect your well. Are there any POE filters appropriate for private wells that use septic systems? And so, that isn't that question doesn't quite make sense, and I'm not trying to be offensive, but it really a septic system doesn't mean you need to add any kind of treatment, right? It only if you have a problem that you've identified by testing, and if for a septic system that's likely to be coliform or elevated nitrate. And so if you test your system and you have that, then when I talked about the shot chlorination, if it turns out that you chlorinate your well and you still have this problem, it could be that your septic effluent is somehow making its way back either into your well or into the aquifer that your well's using, and then it's going to always be a problem. And again, you have two choices: you can chlorinate and disinfect, or you could put a new well in somewhere. But I want to make sure everyone's clear, and I mentioned it earlier, but POE means point of entry. That's typically your softener or an iron filter, where you don't want it to reach any of the plumbing, especially come out of any of the taps, like with iron, because you're going to have that red stain in all your porcelain and in your bathtub and everywhere else and in your toilets. Or a softener, because hard water causes issues for other things, and washer and all that. But for many contaminants, a specific contaminant, and I'll use arsenic as an example, it's overkill. And I mentioned earlier that it's not a dermal risk unless it's super, super high, which we don't see in Illinois or in the US typically. Or it's not an inhalation risk, which some things may be. But POU is a much better option, point of use, and that's typically what you'd use just for your drinking water when it's a drinking water issue that you're trying to change. And so I know on the RO side, the difference between an RO unit and your kitchen sink, not only the upfront costs, but also the maintenance costs is probably 7 to 10 to 1. And RO creates a lot of wastewater that has to be discharged that would be going into your septic. It's there's really no reason to have a POE unit for arsenic. And if someone tries to sell you one, that's why it's important to know those things and to ask questions. Because there certainly are places for POE, right? And there are things sometimes. I can't think of a great example, maybe radon, where it is also an inhalation risk. So radon that comes out of your water. I know it doesn't cause a lot of deaths every year, like 200 maybe is what EPA estimates. But 2/3 of those are from inhalation, where it comes out of your faucet and volatilizes and you're breathing it, and it causes lung cancer. And the other third is stomach cancer from drinking water that has it in it. So, you just need to work with a health professional that knows those things and make sure that you're getting the best advice. So, but again, it all starts with testing your water every time. No matter what anyone tells you. I went to a guy's house up in the Chicago suburbs who was fairly wealthy, and he showed me his basement. He's got, there's literally $10,000 worth of treatment equipment in his basement for his water. And I just said, so what was in your water? That you needed all this stuff. He goes, oh, we never tested. We just wanted to be safe. He can afford that, but it was a waste of money, and is the bottom line. And a lot of maintenance, and some of those treatment devices, if you don't maintain them, like a filter, if you let it go too long, they can grow bacteria, and then they become a source of contamination instead of preventing contamination. So maintenance matters. That's probably the other message I should have put on here. If you don't get a treatment device and just think you can leave it. Most of them need replacement parts or need a filter change or whatever it might be, but they require you being diligent to make sure that you don't turn that device into a source of contamination, because that certainly happens. In Illinois, and I usually don't do Illinois or any other state-specific examples because our audience isn't just in Illinois, but this is really relevant for a number of things, because both our Department of Public Health and the Water Survey, where I work, the Illinois State Water Survey, used to provide testing, and now nobody does. And so I understand a well owner in Illinois would be pretty frustrated by that. We are too, to be honest, or I am at least. And so what do the public do to get tested without extreme costs and difficulty getting samples to the lab? And sometimes, there's only a few labs that might be within 2 or 3 hours. Well, that's a pain. So when someone calls us at our help center, and that doesn't matter what state they're in, we try to provide them with these 4 alternatives. So one, we look up the labs that might be near them, that we are on their state's list, and try to give them those choices so they know and that they can contact them. We don't go. We're not going to go do all your work for you and call them and find out what it costs and all that. You need to do that on your own. But we'll give you a list of labs, so at least you have that. And then we also look to see if there might be a program. Like if somebody calls us from Iowa and doesn't know about their county's program, that's our first step. Call your county health department and see if they have a program available. And that's really for everyone, not just in Iowa. You should find out. There's a week every year that the National Groundwater Association has called Groundwater Awareness Week, and a number of local health districts and county health departments offer free testing for that week only as a way to raise awareness about private well and water quality issues. So you should find out. It's in March. I think it's the second week of March every year. So that'd be beneficial. So third, you can request a well assessment. And I mentioned this already and kind of talked about it, but it's all free. And again, the only drawback there is there are limited resources for that. And so it might be a year or even two, depending on the region and where you're at, before they could get to you. And then lastly, we do recommend to everyone MyTap Score. And the reason is they're using certified labs. They do all the legwork. So you go on their website and you order a kit. And I think their basic private well kit is around $200, which is cheaper than most labs would be able to provide. They ship you a box with the bottles and all the instructions and a little ice pack. They tell you how to do that. Put your ice pack in the night before in the freezer. That morning, collect the samples, put everything, fill everything out you need to, close it up in the box, and put the return label on it, and it's going to go to a lab. And if you look at the address, it may be in your state or a state very close to you because it's a certified lab that they work with. They're not going back to one place. They're going to they have contracts with over 200 labs, as I mentioned before. And then again, because of the volume, it's likely cheaper than an individual lab would charge. And that's what killed our lab, not MyTap Score, but the fact that we're a small research lab and we did offer private well testing even after we had to start charging for it. But we're required to do full cost recovery, and so we had to charge so that the lab would be self-sustaining. And so our prices are much higher than any commercial lab because they have more volume than we do. And it's the same way here. And the advantage really, I think, for the labs is now the lab doesn't have to have a private well expert on hand that can answer all your questions. Somebody at MyTap Score does that. And they work with people all over the country like we do. And so the resources are pretty good, in all honesty. And it's a great model. I wish I would have thought of it. And so we work with them quite frequently. They give us a couple free tests for Groundwater Awareness Week, which we have a campaign called Pledge to Test, where people sign up and pledge that they'll test their well whether they win or not. But then 2 people usually get a free water test out of it, and that's every March. And so, our goal and job is to have as many people test as we possibly can. We're not, we operate like a nonprofit. I'm actually a state employee. Nothing comes back to me. We don't get any kickback from them or any of that stuff. It's just a better model. And so, I didn't compete with our lab. I didn't think that was a great idea for me as a loyal U of I alum and state employee. But now that our lab doesn't do testing, this is really to me, this is the best approach for most homeowners. And so that's why we recommend it. I have a young maple tree growing a foot from my well. Is it a problem? How far away should it be? I would, and the rest of that was, should I cut it out or dig it out? And I didn't put the whole question there. I would cut it out and dig it out. As it grows, the roots are going to fill the area around the well, like where the annulus is. It's been disturbed, so a lot of times that's easier for the roots to move through, depending on whether, not if it was concrete, but it'll find a way. They always do, right? Those roots can get into some crazy places. And we ran into a case, like I said, we actually had someone contact us who had that happen. They had this well, and they had a tree near it, and it was a PVC casing, and they kept getting bacteria hits. And so I said, can you send me a picture? And they didn't tell me about the well. They said, well, it's out in the yard by itself. I don't get what's going on here. And they sent me a picture. And there's like an 18-inch or 20-inch diameter tree 2 feet from the well. And so I was like, I guarantee you that PVC's been squeezed and cracked, and those tree roots have tons of bacteria and bugs and everything else, and that you're never going to get a clean sample. And so I suggested that if it was possible, they put a steel sleeve inside of the PVC casing. So put in basically a well within a well, um, and then that might be their only hope. Otherwise, they're likely going to either have to add continuous chlorination or they're going to need to move their well to a spot that's not near those tree roots. So as it grows, it could, um, for instance, I don't know if you have a submersible pump or not, but if you do, as that tree grows, now all of a sudden, the service rig they use to pull pumps won't be able to set up over the well to pull the pump out because there's going to be tree limbs and everything else in the way. And so it's really just a bad idea. That's the bottom line. And you'd asked about a standard setback. There isn't really a setback for trees, but I would keep it as far away as possible, especially if it's going to keep growing. If you're going to put in a tree somewhere. Um, and so this is just my own personal opinion. I would keep it at least 30 feet away. Um, yeah, and that may seem like overkill, but uh, it's just, there's no reason to have anything near your well that might actually damage your well down the road. That's the bottom line. Do EPA levels apply to babies and infants? What about sodium and sulfate? Should we treat if below an EPA limit? So this is part of 3 or 4 questions that came in from someone who's on today. And so I kind of narrowed it down to this. And I just want to make sure everyone's clear that there are 2 sets of standards that the EPA puts out for the Safe Drinking Water Act. The primary standards are all health-based, and they're enforced. So like in every state, Minnesota Department of Health, New York Department of Health, Wisconsin DNR, Illinois EPA, Ohio EPA, those agencies are responsible for implementing those rules, and they enforce that every water utility in their state provides water to their customers, their residents, that's below these standards. Like for arsenic, it's 10. There's also secondary standards. They're not enforceable. They're not a health risk. They're usually for aesthetic reasons, taste, odor, staining. I mentioned iron staining your stuff, or hardness. There's recommendations because of all the stuff, washing clothes and all that. But the primary standards do consider babies and infants. In fact, when nitrate was first put on the primary MCL list, which stands for maximum contaminant level, it was regulated because of its risk to infants and toddlers, babies. So the story there is, as an adult or as someone who's more than, I don't remember, I think it's a year old, it might be a year and a half, you can get what's called blue baby syndrome. And that's because your stomach isn't acidic enough to break down the nitrate correctly. And so then it forms nitrite, and the nitrite can bind to your hemoglobin instead of oxygen. And that's why babies turn blue. They're basically suffocating. And so that's why it's on the MCL list, the primary list in the first place. At the time, there was no evidence that nitrate causes problems in adults. Now there's a whole body of research that half of it says it's a problem, half of it says it's not. And so the EPA hasn't moved to do anything about that. But babies and infants are considered, to answer your question. Now, sulfate and sodium are both secondary contaminants, which means they don't have health risk. But as we talked about earlier, if you are on a sodium restricted diet, which is why that example is so powerful I used earlier, one, your water softener may be causing a big problem for you, right? If you're using sodium chloride instead of potassium chloride. But any sodium, if you're on a restricted diet, it makes sense to try to reduce that as much as you can. So, because then it is a health risk, right? Where it isn't for someone who doesn't have that restriction. And so the last question, generally, as far as treating below the EPA limit, generally no, you don't need to treat for health reasons. Excuse me, health reasons. But again, if you have high iron and everything's getting stained with that iron rusty color, then you're going to want to treat because it's just a nuisance. And the one exception to that is manganese. In the last 8 or 10 years, it's been proven that manganese has neurological effects, especially on children. And so far, the EPA hasn't moved to try to regulate it as a health risk, but a lot of states, uh, Canada, everybody else does regulate it. And now there's health advisories and guidance that the states and even the EPA's put out about manganese being a health risk, but it's still not formally on the primary contaminant list. And so when you see that as a secondary contaminant, um, it's really not. It should be regulated, and it should be, you should minimize it. And so, uh, especially for children. And what I know, at least from Illinois groundwater, is we have a lot of both iron and manganese naturally occurring in our well water, in our groundwater. And so, yeah, this happened with my niece. She is a farmer. She's got two little kids. She sent me her water result, and it was really high in manganese. And so it was like, don't drink this water. And certainly don't let them drink this water. So, and they needed that treatment. So, I think last question, I know I'm over. Uh, is there a minimal amount of lead detected in water that's safe to drink? So this is really a question for your doctor or a health professional, which I'm not. I'm a groundwater hydrologist. But that said, all the recommendations we see from health professionals say there is no safe level, especially for children. Um, and what's ironic here is the Safe Drinking Water Act doesn't have a health-based standard for lead or copper, and there's probably a number of reasons for that. But instead, what they do is they require a public water supply to sample in homes. And the reason for that is because most of the lead you see in your water isn't coming from the water that your water utility is providing you. It comes from the pipes, either in your home or their lead service lines. You hear that term a lot. And so they sample in homes, and 90% of those samples, and how many samples they collect is based on how large the town is, have to be below 15 ppb. Well, and this is all changing. They're passing new rules. So it's really not a health-based limit. So if you see 15 ppb as what the Safe Drinking Water Act requires, that's misleading, because that's not saying that below 15 it's safe. And I would say you want to have none. Um, yeah, again, what complicates that is it could be the pipes in your home that are causing it. So even after all this is being spent on lead service lines, so that a utility is replacing the lead between the main and where your meter is into your home, if you're on a public water supply, it doesn't mean that you're still not going to have lead, because you might have lead pipes in your home. And so it's on you as a homeowner to understand that difference and find out what kind of pipes you have. If get it tested, make sure that you're not seeing lead. You just really need to do your due diligence there. And there are filters that do a great job of removing lead. You just have to use it and know that you have it. Even some of the pitcher filters do a good job of removing lead. Some don't. And again, it's back to which of those have been certified to remove lead. That's the ones you want to use, um, because they do work. So it's actually a simple fix, but you need to make sure you're getting the right kind. Okay, so on to our questions for today. And again, I apologize for running along. Let me pull these over. See that okay, Katie?
Yep, it looks great. Can you hear me?
Thank you. Okay, so I'm a local health sanitarian in Connecticut. If a licensed well driller wanted to drill a well on a property served with public water with the intent to use the well for irrigation purposes, is this okay? That depends on your state laws. I mean, it's so early on, whenever these rural water districts were going in all over the country, there was no requirement to fill in or seal your well. And what happened in many cases, many different utility districts, is that someone decided they didn't want to pay their water bill, and so they hooked their well up, and then they had cross connection issues, and they actually contaminated the potable water coming from the utility. Most states and most towns have laws preventing you from putting a well on property um, that has a public water supply, which is good. And I mean, if it were your choice, I would not let them do it. Unless I mean, there's other people who know a lot more about this than I do, but I just know that in Champaign-Urbana, we just now allow a, a, a well, if you will, a well to be drilled. It's not a well into our aquifer for geothermal, and that took years and years of work among the people who are interested in that. And I mean, it's a great savings for energy, but it's also, you have to protect the aquifer, and so that's the issue. It's both protecting the water supply if it's a public utility. And has the public utility weighed in on this? Because I would ask them. I know in Illinois, our public water utilities have a lot of clout, if you will, or a lot of leeway to dictate those things to prevent that from happening. And so I don't know the answer in Connecticut, but I would ask the utility. I would ask your state primacy agency, um, the folks that regulate water utilities in Connecticut. Boy, and I was just at a meeting last week actually with some of your staff from the state. I'm drawing a blank. Anyway, that's how I would approach that because I would guess there's some rules. Are you concerned with separating distance from the public water source to the private well? Will you require a water analysis report be done on the water quality when intended uses for irrigation? I'm assuming the same person. It's not about a separation distance because the private well is pulling from an aquifer and the public water source, I'm assuming it's not the well, it's just the pipes coming from, it's a distribution system. So, but if it's, because I know there's also a lot of rules related to what you can do near a public water supply well. And again, it's the same folks. It's your state regulatory agency for compliance with the Safe Drinking Water Act, which I believe is the Connecticut Department of Health. Yeah, and we're not regulatory as far as a water analysis. That's also state by state what's being required. I will say that Connecticut was one state where I talked to the person who ran a local health district, and she said she had the power to condemn wells, and I was shocked. So yeah, it's home rule states have a lot of different rules that locally give some of the local health districts some power, and that's to me it's not a great approach because yeah, that's another story. How is alkalinity different from pH? Well, I would, to really answer that correctly, I need to look it up and make sure I give you the right answer. I think I know, but I'm not a chemist, and I want to make sure that I would provide that correctly. And so I probably should know the difference, but I mean, pH is really a matter of how reducing or oxidizing the water is, with neutral being 7. Yeah, I email me and I will give you a much better answer. Actually, Claude or Google probably can give you a really good answer as well. I've recently heard of someone with radon in their water. Is that often an issue? Yes. It depends on where you're at. You know, it's a huge thing in the real estate market because of radon upwelling into basements through cracks or whatever it might be. Radon mitigation is a lot of times required for any of the folks that fund home loans, but it can also exist in your water. And the page I referred to, EPA has on the number of deaths from radon in water has been archived, and so to me that says that they don't consider 200 deaths a year as a real huge risk nationwide, if you will. I'm just guessing that, but it can be tested for. It's because it's volatile, like any other thing that's volatile. It's a little harder to test for because you have to make sure that you're not releasing that when you collect the sample. But there's folks that can come out and collect samples and do that. But if I would contact, again, your local health department or your state health department, or maybe even your state geological survey or your USGS office in your state, and ask them if any work's been done to look at radon in water and in the aquifers in your area. That's how I would start with that, because they should know. Somebody should, if it's a problem. My hot water only smells strange. It's probably the rod, and you can go to our help center and look that up, I think. But a lot of times when it's just the hot water, it's because of the type of rod you have in your water heater, and you can change that to boy, it's escaping me, to a different kind of rod. You know, the rod for the corrosion, all that stuff, and it'll go away, because it's and actually Minnesota has a really nice little guide that explains that. So if you email us, I can send you that. It says, is it all water, hot water, and it's a rotten egg smell, I'm assuming, or something close to that. So there are resources though for that. What are the two states that have no well construction regulations? I'm glad you asked. So that would be Pennsylvania, which is kind of shocking, and Alaska. And I know Alaska has a work group that's really trying to get that changed. And I have no reason and no guidance to give you on why Pennsylvania is that way. I know I on one of these webinars said Pennsylvania has no well construction code and they don't license their drillers. And somebody from Pennsylvania emailed me and said I was wrong. Here's the page where you for licensing, blah 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 blah. And so from that time on, usually anytime I say it, I have a slide ready. You and I can both pay our $60 without a test, without any continuing education, and be a licensed well driller in Pennsylvania. And so it's not true to say that you don't have to be licensed. It's just you don't have to have any skill or any correct equipment or anything. And but you do have to pay $60 to put a well in. So to me, that's not having driller licensing, because in every other state you have continuing education credit. You have to pass a test. You have to follow rules, all those things in order to put in a well. So yeah, that's where that's at. I'm glad to discuss further. All right, well, thank you everyone for sticking around. Yeah, have a great day.